So today's topic is relational model. So here we are moving from ER model to the relational model. In the last unit, we designed one ER model, correct? In which entities, relationships, weak entities, the works, so everything was being done and it came out so nicely. So now, what we have to think further? I gave you one question also in the last of the video. I hope you have gone through it, and this slide basically will tell you the answer. Okay. So the thing is like, look at the patient. Okay. This is our patient rectangle, which is our entity set. This one. So we designed this in ER model. Now think about it. That this is a set. It is generalizing the complete set of patients. So if I'm talking about one patient, Ravi, suppose, okay, where does the actual data of this patient live? Where this the patient ID, suppose it is 101 and the name Ravi, there can be another patient, suppose Priya, okay, ID is 102, okay, so where it will go? So it can be stored like this as a data. Hmm? Yes, you must have seen the data in different organizations. If you are going to hospital also, they maintain the data in the form of a table. So this representation you can understand very well. So this is a patient ID, name, date of birth, and ward number. These were the attributes, if you remember. Yes. So rectangle is telling us that it is an entity. But where will the data go? It will go into the table. Now we have to convert our ER model in the form of a table. Yes. So our diagram, the ER model is not a database. It is a design, conceptual design. Correct. Now we have to convert it into a tabular format. So the name of the patient, the date of birth of the patient, ward number, where the patient is being admitted. Correct. So that is the thing. And that is all about the today's topic. I hope you got the understanding what we are talking about. Now we are evolving our conceptual design into relational model. That is the thing. So let's go further. We have to store the rows, so that we can search, we can update the data, and this will be our discussion. Okay, then the things that we are going to utilize. We already understand certain things, some ideas from our unit number 1. Correct. And here we are going to transition them into certain other things. Like entity set now becomes a relation. Relation means if I'm utilizing the term relation, that means it is a table. So the entity set will become a table. Patient. So that will be a table name. Patient. So I can write over here so that I can show to you. So suppose this is a table. In Excel sheet, you can imagine it like this. Okay. What will be the attributes? Different attributes of the patient's were name, date of birth. That will become our column. So the patient table will have different columns. Yes, name, date of birth, patient ID, ward number, like this. These were our attributes. So it will come over here as a column name. Entity 1, that is row. So from the entity set, there will be first entity. That means data of the first patient. Suppose it is Ravi. So name is Ravi. Date of birth, it will be whatever the date of birth is of the Ravi. Patient ID 101. Like that. Ward number W3. In this way, it will be stored. Set of allowed values. What will be the domain? So like valid data we have to give. Like name is only characters. Name is only characters. Date of birth, valid dates. Correct. Patient ID, numeric. So in this way, we have to give a domain. What is the data type? Either it is numeric or it is character. Okay, or it is date of birth, date, I would say. Okay, so that is the thing. So these things now we have to transition from our ER diagram. Yeah, good, good. I hope you got the understanding on this one. Yes, now next is degree, number of columns. Yes, degree will tell you number of columns. Hmm. Cardinality means number of rows. You will get to know how many number of rows. So different meanings from unit 1 we have to draw for our relational model. Correct. Now let us see. We are moving further to convert our ER design into a relational model. That is our table. Now comes this term. We have already discussed about it in the previous videos also. Schema and instance. So what is schema? Just a repetition because now we are talking in terms of tables. Schema is a structure. So patient and its attributes will tell you the schema of our table. Correct. That is patient and its attributes. Patient ID, name, date of birth, and ward number. Column names plus their domains. And it will not change. It will rarely change. Okay. If we are going to update something, yes, we can do it. There are queries for that. There are some commands for that in databases, utilizing which we can change it. Okay. But usually it should be fixed. If our ER design is fixed, then it will be fixed. Okay. Next is instance. Instance is basically a picture or screenshot of the data and which will change constantly. Like right now, my patient data is this, suppose Ravi and Priya. Date of birth is given, ward number is given. Suppose this patient is now cured and now left the hospital. Correct. Now new patient came. So we have to update this. So we have to update that data. Correct. So it changes. It changes. So the current picture of the database, of the table at the present time will be your current instance. New patient, new row will come. So this picture will again change. This instance will again change. Okay, so schema will be one, but there will be millions of instances over a period of time. Correct? So that I wanted to make you recall from our previous video and it will be utilized in the tables. Now next, what are different types of keys that we have to understand for our tables? Okay, so first one is super key. We already understood one type of key, unique key. Unique. That means the key attribute that we have seen in the previous ER design. What was a key attribute which identifies that entity uniquely? That is our key attribute. So there are different types of keys. That unique key will only assign the one primary key. Okay. So here see, there are three types of keys that you have to remember. First one is super key. Super key. It is any set of columns that uniquely identifies a row. That uniquely identifies a row. Okay. Super key like patient ID. Patient ID and name together. Patient ID and date of birth together. So that makes it like a super key. Okay. Yes. So suppose two patients have same name. It can happen. So that's why it is written as patient ID and name. So you can understand it in this way. Patient ID, name. Suppose two patients have same name, Ravi and Ravi. Okay. And their patient ID is 101, 103. Now, how will you, identify Ravi, the patient first? And how will you identify this Ravi, the patient third? Then you can take a combo of both together. 101 Ravi and 103 Ravi. So that didn't remain same because now we added this patient ID with it. In the same way, two people can share same date of birth. Okay. Then how to identify them uniquely on the basis of their patient ID? We can add it. So super key. It uniquely identifies a row. I hope you got it. Yes, please drop your comments for any doubts. Okay, now next one is candidate key. So second one for us is candidate key. So it is a minimal super key. We have to basically divide. That means it is the one with no with no unnecessary columns. Basically, divide your patient ID plus name down. Okay. So if you have patient ID and name together from Superkey, yes. So divide it. Patient ID and name. Okay. That's a candidate key. So your patient ID will be a candidate key because it will uniquely identify, because it is uniquely identified. In the same way, if you have Aadhaar number of a patient, yes, so that can also uniquely identify. So both can identify a patient. Okay. Now next one will come as a primary key. So the one candidate key that we can choose to utilize. Okay. So if you have two attributes like patient ID and Aadhaar number, any one of them you can choose as a primary key, but there will be only one primary key. There will be only one primary key for an entity. Correct. Only one primary key, either patient ID or Aadhaar number, and that will be underlined if you remember. Okay, that will be underlined. So if it is a patient and it is a patient ID, we have to underline, and it is our primary. Okay, so that is the difference. So every candidate key is a super key. The primary key is a candidate key. Okay, that means you choose from the candidate keys only one as a primary key. That is the thing. So here relationship is nested. Every candidate key basically is a super key and the primary key is the candidate key. Correct. I hope you can remember these things. These are very crucial questions for Viva also. Now, let's move further. Please remember these things. Next type of key, very, very important one, and it has been asked in Viva a lot. So, asterisk it 2 times, 3 times. Okay. So, here what happens is that now we have to connect the tables. Now, because first we understood how the tables will be framed. They will be framed on the basis of the entity. Entity. This was another entity. We have given them names, correct? That is table name. And then their attributes became their column names. Now you can see that this ward number has two wards, W1 and W3. Now the thing is how they will connect the relationship part, the diamond part. What happens is in this table, the patient can occupy only those wards which are existing in the ward table. That means which are having some existence. You cannot, if the ward table has only W1 and W3, then we cannot give any patient ward number 2. It will be wrong because it is not existing here. It is not existing. Yes. So ward number in patient table must match a ward number in ward table. That is the thing. So here, if you will see in ward table, ward number is a primary key. It is underlined in a yellow color. I'll clear it. Yeah. So ward number here, it is a primary key. Then what will be the ward number here? Will it be a primary key here? No, because patient table has one primary key already. Patient ID, which will identify the patient uniquely. Now here, what ward number will represent? So it will be a foreign key, FK, foreign key. It is a foreign key. Correct. So it is a column. So this foreign key is a column which points to the primary key of another table. That is called as a foreign key. Got it? A column that points to the primary key of another table. So this is an admitted relationship from ER design, if you remember. So here, no diamond is being utilized. We have to connect these two tables utilizing foreign key. In this way, we are utilizing the ward number in the patient table. Yes. So your link should be honest. What if I put ward number equals W9 in patient when no ward number W9 exists? So that will break the link. So that will become a, what? A wrong data. Yes. So we have to follow some constraints for that. And that also will see one that some constraints we have already seen, domain const. Yes, that we are going to see now further. We have to follow some constraints to maintain the integrity. These are the rules. So that we are going to see now. So the word number which is not even existing, but can we give it here? No, it will break one rule. So let us see and move forward to those rules. So these are called as integrity constants. There are four types of integrity constants. Let learn them one by one. First one is domain constant. What is the meaning of domain constant? That means every value must come from the allowed set, allowed data type. That means age. Age cannot be 200. If it has been set that age should be between what? 18 to 35. Suppose. Okay, suppose we are gathering some data, the people who can vote. So suppose here we can say 18 to 18 onwards, greater than 18 will be. Okay, but less than 100. Okay, okay. So 200 will become invalid data. So that is one rule we kept in our database. Date of birth cannot be a character. Yes, it should be a date. So it will become wrong. So the domain set allowed the range which is being set only that you can give. Next is key. Second one is key constraints. So no two rows share the same primary key value. Yes. Now the thing is two patients with patient ID 101 are not allowed because it is anyhow a primary key. Yes. And it cannot have the same ID. If two students will have same roll numbers, then like Ravi and Priya, no, not allowed. Priya cannot have the same ID as the Ravi has. Okay, so that is the thing. That is not allowed. Third one is entity integrity. So what is the meaning of entity? Entity means the primary key can never be null. So here we cannot write it like any new patient suppose came XYZ and here it is null. No, nothing is there. It is not allowed. It is not allowed. It should be filled. Some ID should be assigned. Then only they can be admitted to the hospital. Yes, that is the meaning. Then next one, referential integrity. Referential integrity means reference means it is a foreign key. So foreign key must match an existing primary key or be null. Yes. So word number W9, there is no such word, so we cannot give. So you can right now keep the word as null if that word number is not existing. We can assign the word later on in a time being. Okay. Yes. And that can be decided once the word will be available. Correct. So that is the thing. So you cannot give some, you know, um, undefined values. That is to maintain referential integrity. I hope you got some idea. Please remember, very, very, very important question for your exam. Now, next one. Okay, so that is after this, we have some actions. Okay, referential actions that we have to decide. And these are some rules. Okay, so you remember weak entities from the previous part. What are weak entities which does not have a primary key? Suppose you have two tables, the example that we have taken till now, patient and ward table. If we will delete ward number W3, what happens to the patient Ravi and Ahmed? Because they both are been admitted to ward number 3. Okay, so what will happen? In that scenario, database recommends to utilize on delete cascade. That means delete the patients too. That means delete the dependent table also. Dependent part also, the foreign key. Correct. The child dies, the parent also dies. That is the meaning. So if W3 is being deleted from the word table, that means now W3 is not existing. Then from the patient table, the patients that were belonging to that ward should also be deleted. I'll show you that table again. So it is this one. So suppose we are deleting W3. Suppose we are deleting W3. Now it has been removed. Ward 3 is been removed. Then we have to remove this also. Yes, but what will happen to the patients? We have to assign some new ward. Okay. But what if your database is not using on delete cascade? Then what will happen? Ward number is being removed. Ward is being removed from the hospital. Correct. But still, Ravi, the data of Ravi is being pointed to W3. That Ravi and Ahmed are part of W3, which becomes wrong data. Yes. So it is violating the rules of database. It will create some problem. Okay. Now see. Yes. Where were we now? Yes. On delete cascade. So if the child dies, the parent will also die. That is a mean. Okay. Now next one, on delete set null. On delete set null. Now keep the patient set their ward number to null. That is the meaning of this second one. That only we were doing right now. I was just telling you this thing only. So the second rule, use on delete set null. So if ward number 3 is being deleted from patient table, that was ward number. If W3 is being deleted and here W1 was there, then we have to set it null, so that we will not lose this data of patient, because the patient Ravi and Ahmed are still existing in the hospital. Correct. Then third one. Third one is what? On delete restrict. Here it is a restriction form. Refuse the delete while patient still point to W3. That means until and unless you are not applying this, it will, what it will do? It will not allow you to delete the data because foreign key is still existing in your database. Correct. Great. Great. So this is the on delete cascade that I discussed about earlier in our one of the previous lectures, and we'll be utilizing it in our SQL queries. So that is the thing. Let's move further now. See, now this is one question for you. Okay. So pause the video, try it once, and then you can match your answer. Okay. So here one schema is given to you, enroll. And enroll has some attributes: roll number, course ID, marks, and semester. A student can take many courses. A course has many students. So remember this. You have to apply it to make your table. What will be your primary key? Is roll number a foreign key pointing to which table? So you have to find out the primary key and foreign key pointing to the primary key. So which constant stops marks is equals to 150? Marks cannot be 150. So which constant will stop this? Which constant stops a null in the primary? Yes. So give the answers to these ones and then match your answers. So these are the answers. So in this scenario, what will happen? Roll number, course ID, marks, and semester. Yes. Now here, only roll number cannot become a primary key because student is enrolling in some course. So we have to take a composite key. That means combination of both, two keys, combination of two keys. Okay. So one roll number can take two courses also, and one course can be taken by two students also. So why this is happening over here? Imagine this scenario. See, this is your table of enroll. This is your thing. Here you have, I'm just considering two columns right now, roll number and course ID. So suppose roll number 101, 102, and 101 again. It has taken a course. Suppose it is one major minor degree course. So suppose they have taken two courses, CSC as major course and then electronics as minor course. So 101 belongs to two courses. Correct. And next thing, again 102 has also taken CSC. Now see, in this column, you can see there are CSC is appearing two times. And in this column also 101 is appearing two times. So roll number cannot be unique alone. Course ID cannot be unique alone. So what we have to do? We have to take roll number and CID together. We have to make them as a primary key. And that is called as composite key. Okay. That is called as composite key. So then it will be a unique 101 CSC. 102 CSC, not same together, and 101 ECE. But if you will take them separately, these two will be same and these two will be same. That's why primary key, in this scenario, our primary key will be roll number and course ID together. Now, why roll number is a foreign key? Because we will have a two tables, one student table and one course table, in which it will maintain course ID. It will act like a primary key here, and here SID, student ID, that is roll number. Okay. And in this scenario, this roll number here, it will act like a foreign, because this roll number belongs to which course, to understand that. Or here we can give as course ID. So in this scenario, in this table, course ID will be a foreign. Okay, from the course table. That is the thing. Okay, then domain. Which domain? Domain constant stops the marks 150, because if we are giving the range it as 0 to 100, maximum marks is 100. So in domain constant, we have to give it the rule that range should be between 0 to 100. So it will stop it. That is one answer. So we already studied it. What constraint will stop the value null? In entity constraint. Okay, entity integrity constraint. No part of the primary key can be a null. Okay, then I hope you understood these things. From the exam point of view, there are some questions that can be asked, like explain integrity constraints in the relational model. Yes. Then differentiate super key, candidate key, and primary key with examples. What is foreign key? Explain referential integrity, because both are related to each other. Schema and instance, very much asked question in Vivas. Degree and cardinality of relation. Please make a note of these questions. These are very much required for your exam purpose. Okay, so before I close the video, there is one question for you. That is what? Suppose we now have some tables and we have some constants also. Now, how do we ask questions? If suppose I want to search some data, show me every patient in ward number W3. There is a precise math for this. Yes, correct. So check how you will get this answer. And in next section, we'll start our relational algebra. Gradually, we are moving towards our MySQL and we'll be executing queries on different tables. We'll be developing our own database and we'll be searching it, updating it, analyzing it. Yes. So, okay, students, thank you for watching my video. Please subscribe my channel, share my videos. Thank you so much to become family. For me, this is, really a motivation. Thank you once again. See you in the next video.